researching. So this time I kind of got a little ahead, so you didn't have to see me write the useless code. And I put a little brief thing here, an array that we're gonna look at to determine how binary searching works. Now, this is important. We need the array to be sorted because what binary searching is it's kind of like quick sorting, like the same idea where you have a pivot and then you kind of split the array, but in this case we are only gonna we're gonna choose a side of this that we kind of split it to. So for example, if we have this array, how can we determine the most efficient way to look at this list? Okay, we look at one of these middle values. Maybe it's easier to start with actually a 5-element list. Let's just do 1, 2, 3, 4, 5. Now we will start with the center value, okay? Which is the index 2. Okay, index 2. Now we know that this list is sorted, so if we're searching for something like 1, we know that if 1 is less than 3, then we need to search on this part of the list. Unless, of course, that we're searching for 3, then we first check if there's equality with this midpoint. Otherwise, if it's greater, then obviously we check on the right side. And if it's not there, not in the list, we would need to also check whether the length, if the length is 1, then we gotta make sure if the value is not equal to the value we're searching for, then we return, I don't know, we'll return -1 like the linear search. So let's start it off by just giving an array. I always like to create an array first. Let's use this array. It's kind of easy. And then we'll say int a length is equal to 5. Then we want to call binary search on a length, and we want to see, we'll search for 5. Just for simplicity, I've copy pasted it. We're just going to add the include statement for printf. Now to start with binary searching, we wanna, as I mentioned, have a low and a high value. So let's set low. We can start it off as 0. I'll explain the code in a bit. Equal length -1. Okay. Control I, format that. Now we can split this up into many fragments technically. So realistically, one condition could be length is 1, right? We want to include that in our search too. So what we're going to do is we're going to iterate through everything, okay? Through a loop. So let's use a while loop, okay? Now, if this while loop fails, if I'm unable to find a value while iterating through the whole list, I'm just going to return -1. As I mentioned in the linear search video, I want to return something that is not a possible array index. Now here, what do we put here? the length can be 1, okay? If the length of this list is 1, then high and low are going to be equal, okay? So we always want low to be less than high, right? But we need to consider if length is 1. Let's add an equal to with it. So if it's lesser than or equal to high, we're going to run this loop. We're going to find the midpoint, okay? I like to use brackets, parentheses, and it just makes the code nicer to read. You don't have to worry about precedence of equations. So we have our midpoint. Now we'll have an if statement here. If the array, the midpoint, the value at the midpoint of the array is equal to, first we want to check equality. If it's equal to search, then you just return where it's equal. That's just the midpoint, okay? Now we have 2 more possibilities, right? If just copy this, if it's greater than search, that means, yeah, this might be a little less confusing. If the value you searched for is lesser, you could do it both ways. I'm just trying to make it more conceptual. If search is smaller than the array, then what you want to do is you want to change our low and high points. So we're going to just say low is equal to, we don't even want to change our low point, we want to change our high point. Say high is equal to array, sorry, high is equal to mid minus 1, okay? Now why is this? It's like you want the left part of the list because everything on the left is smaller. So mid minus 1 is your new high point, okay? So for this list, say we want to find the value 2, then we're going to start with our midpoint 3. Now 2 is lesser than 3, so we're going to only search to the left of the list. So now the highest point is length minus 1 minus 1. Sorry, not length minus 1. The midpoint position minus 1. It's because, yeah, we're going to be exclusive. Otherwise, well, why don't we just return? Why don't we just change low now? It seems like this should work, right? Let's try it. So let me set this as a run file. I included the standard IO, but I should print the value that we get. Now, is 5 on list A? Yes, it is. So we want this to give us 4. Let's do a few more tests just to make sure we're solid. Let's do 1, 2. Let's search for, I don't know, let's search for something that's not on the list, like -3. Let's search for, I don't know, something else. Let's search for the other side on the list, and let's search for the midpoint itself. Okay, let's see. Okay, there's a problem. Now what is this problem? Let's see. I wrote print instead of printf, and I need to put in my format specifiers. Oops. Okay. 4, it's in the 4th position. Is that true? 1, 2, maybe 0, 1, 2, 3, 4. That's true. We wrote it here as well. -3 is not on the list, so this should give us -1, and it did give us -1. 1 is in the 0 index. Yes, we got the 0. 3 is in the 2nd index. So we got 2. Thank you. I hope this makes sense, and if you have questions, then feel free to ask.